Hey guys, in this video we're going to have a look at an algebraic equation factorization strategy known as splitting the middle term. And previously we've looked at factorizing by grouping pairs. This is a little bit of an extension on that and applies to a lot more cases than the grouping by pairs technique did. And it's something you can generally use a lot of the time in factorizing in general. So these are the questions we'll have a look at. Let's start out with the first one. So previously when we did the grouping by pairs, what we did is we tried to take out a common term from each of a couple of the components. If we had 4 components, we'd group them in pairs of 2, and then we'd find a common set of terms we could take out of each, which would leave us with our other 2 terms, and that would help us form our 2 sets of brackets. So for this first example, let's look at following a similar process. Let's split out this 6x and see what happens. So if we take this 6x and we split it out into, let's split it out into 2x plus 4x. So we know that 2x plus 4x gives us 6x. So we'll just represent it like this. And we'll leave the 8 as is. Let's then group the first couple of terms together and group the last couple of terms together like we did in the grouping by pairs technique. And then let's take a common factor out. X outside of the first one, that leaves us with x plus 2. And if we take x outside of the second set of brackets, leaves us with x plus, I beg your pardon. We take 4 out of the second set of brackets. Then it will leave us with x plus 2. So as you can see, we've got the same bracket pairing in both. And using the grouping by pairs technique, what we can do is write the x plus 4, which are the 2 terms outside of this common factor, and then represent the common factor. X plus 4 in one set of brackets, x plus 2 in a second set of brackets. And if we were to expand this out using the distributive law, so first term times the first term plus first term times the second term, etc., as you're familiar with, we would end up with this same result, x squared plus 6x plus 8, to verify that we're correct. So that's still the grouping by pairs technique, but let's have a look at this same question now and apply the splitting the middle term technique. And I'll leave the answer there so you can see that we end up in the same spot. So the basis here for this technique is that when we have an equation, x squared plus bx plus c, in this case b is 6, c is 8, and we want to represent it as x plus something multiplied by x plus something. They might be the same, they might be different. What we do is, for this splitting the middle term technique, is we split this middle term across these 2 values, and what we're looking for here is a value b that adds together and half goes to each of our set of brackets. And then what we're looking for our value c is also a combination of both of these terms, however, multiplied together. So the easiest way to visualize this, it looks a little bit confusing here, is essentially we're looking for 2 numbers that multiply together to give us this term, and that add together to give us this term. So let's get rid of some of this middle section. And a lot of the times this is just trial and error. You just have to kind of think what fits best. In this case, we know that the rest of our formula, or the rest of our solution, is going to be, we just need to fill in these 2 numbers. So a good way to start is to have a look at all the common factors of the last term, c. So in this case it's 8. So what are the factors of 8? We have 1, 2, 4, and 8. And then just to test out each of those combinations. So let's say we had 1 in one of the section, in one of our brackets. That means we'd need to put an 8 in our second lot of brackets. But then we can test out our second law or second attribute which must hold true, which is that the two numbers must add together, multiplied by the x term, to give us the middle term. In this case, if we were to expand this all out, we'd end up with plus x and then plus 8x, and that gives us plus 9x total. X plus 8x equals 9x total, which doesn't equate to the 6x we're looking for. So we know that that's not the values that fit in this set of brackets this time. So what are the other factors? Well, we've got 2 and 4, as we mentioned before. So let's try those. 2 and 4. And this time, as you can see, because we already know the solution here, that is going to be in fact our answer, because 4 times 2 gives us 8. And this time, it also satisfies the requirement that plus 2 times x, which is 2x, plus 4 times x, which is 4x, is going to give us a total 6x, which matches in this case. So a lot of the time this is trial and error, as I mentioned. You also get the hang of seeing what fits in an equation. Let's have a look at the second example, and we'll move through it a little bit faster so that you get the hang of it. So this time we'll do x squared plus 8x plus 16, and like I say, the more practice you get, the better you'll get. So this time we're looking for two numbers which multiplied together give us 16, and two numbers which added together give us 8. And I hope you can see this time the number we're looking for is, what are the factors of 16? Firstly, it's, well, 1 and 16. We've got to find factor pairs, 1 and 16, 2 and 8, and 4 and 4. And 4 and 4 is indeed our answer, because none of the other combinations would give us a total sum of 8. And of course, x plus 4, we can represent this as x plus 4 all squared. So hopefully that made sense to you. Let's have a look at the third example. K squared minus 4k minus 21 equals, and this time, once again, two numbers that multiplied together give us negative 21. This time we've got that negative in there, and two numbers which added together give us negative 4. So let's start out with the factors of negative 21. Well, the factors of 21, firstly, we've got 1 and 21 and 3 and 7. And it's definitely not going to be 1 and 21. No combination of summing, even incorporating the positives and negatives together, will give us negative 4. But 3 and 7 do. They have a difference of 4. So straight away that indicates that our second values must be 3 and 4. It's just, in this case, the difficult thing to work out what needs to go in the middle. Is it plus or minus of each? So we know that, using our general rules, that a positive and a positive is a positive, a negative and a positive, or vice versa, is a negative, and two negatives results in a positive. It's an important thing to keep in mind here. We know that our resultant multiplication is negative, which means that one of our terms must be negative and one must be positive. But which one? The key to working this out is to look at the sum term, which in this case is negative 4. So some combination of 3 and, this should be 7, not 4. Some combination of 3 and 7 are going to give us negative 4. And of course, it's not going to be negative 3 plus 7. That'll give us positive 4. It's going to be negative 7 plus 3. And that's our answer. It's going to be k plus 3, k minus 7. And of course, if you're unsure, you can expand the brackets and make sure you can get back to using the distributive law back to the original equation. So, and one last example. So this time x squared minus 13x minus 30, or plus 30 rather. So that's our equation this time. And hopefully you can see pretty quickly that the factors here this time that are going to help us out, factors of 30, a factor pair that will help us is 10 and 3. So negative 10 minus 3 gives us negative 13. So here it's going to be minus 10 and minus 3. And of course, negative 10 multiplied by negative 3 gives us positive 30. And that's why this term here is positive. So that's it. That's the answer to the final question. And like I say, you can always work backwards to use the distributive law to work out whether you get back to your same original equation. And if you do, then your factorization is, of course, correct. So that's going to be it for this video, guys. Thanks for watching. Hope you enjoyed. Leave any questions in the comments below, and I'll catch you guys next time. Bye.